1 times how many a's will equal to 1? Since we already have a 1 here and we don't really need any of these a's, we could say that a zero number of a's would equal to 1. In other words, if you were asked to find the log base of a for 1, then this would equal to 0. This is true for any base of a. Or if you were asked 1 times how many a's would equal to a, the answer of course would just be 1a, because that's all it takes to multiply 1 to get a. So a to the power of 1 is a, or log a of a equals to 1. That means any base with a matching product will always equal to 1 because you only need one instance of it. These are the two simplest laws you can learn in logs. And today on MathBase we'll be going over a couple more laws which are a bit more complicated than these two, but it'll be tying back to the ones that we learned in the previous video. Let's say we were asked to find the log base 3 of 9 to the power of 5. This is a very large number and can be difficult for most students to work out. You could use indexing to change the 9 to 3 to the power of 2. That's one way to deal with this situation. Another way is to use this law. Log base of something of b to the power of n can be rewritten such that the n, the power, comes out to the front, and you're left with a much simpler log expression to work with. So log base 3 of 9 to the power of 5 can be rewritten as 5 times log base 3 of 9. And we know that 3 to the power of 2 is 9, which means that this can be simplified as 5 times 2, since log base 3 of 9 would equal to 2, and this equals to 10. Another situation might be having a negative log base 10 of 2, which means you can use this law in reverse now, since there's something at the front. And so you could say log base 10 of 2 to the power of negative 1 is the alternative way to write it. And that can simplify to log base 10 of 1 over 2 using an index law. This could also be generalized as any negative number in front of your log, such that if you bring it in, you have log base 10 of 2 to the power of negative n, and this can be simplified as log base 10 1 over 2 to the power of n. There's another situation where you could use this law, and that's when you're trying to solve equations for the value of x. So for example, if you had 2 times log base 10 of x minus log base 10 of 4 equals to 2, you can firstly bring the 2 in so that it's log base 10 of x squared minus log 10 of 4 equal to 2. And then using a law from the previous video, you could use this minus as taking the insides and dividing each other. So this would be log base 10 of x squared over 4 equal to 2. And then using a conversion from a log equation to an exponential equation, you can say x squared on 4 equals to 10 to the power of 2. 10 to the power of 2 is 100, and so x squared would equal to 400. And we know that either 20 squared or negative 20 squared could equal to 400, but we're only allowed to say that x is 20 and not negative 20 because you're only allowed to have positive values inside a log. Originally, that's where the x came from in our question. So if you had something like log base, any base, to a zero product, this is simply undefined. It's not possible to find an answer for this. It's the same if you have log a of any sort of negative number. The bottom line is whatever goes inside a log needs to be positive. Now let's say you're asked to find log base 16 of 8. It looks like they could work together, but nothing really goes into anything here. But they do have something in common, right? 2 to the power of something would be 8 and 16. And we can use this special law, log a of b equal to log c of b over log c of a, to make these two elements work together. And c can literally be anything as long as it's the same for both of them. So in this case, we could say log base 2 of 8 over log base 2 of 16. And we know that 2 to the power of 3 is 8, so that's 3 on top. Log 2 of 16 would be 4, since 2 to the power of 4 is 16. And that's your answer. You can also use this law in a slightly different way. Since we can let c be anything, you could use b as the base for both of them. And since log b of b is equal to 1, this can simplify to log b of a as a reciprocal. What's nice about this effect is that you can actually take these two elements and swap them around. So if you had something like log base of 16 of 2, this can't really be worked out, but we can flip it around by saying 1 over log 2 of 16, and that will equal to 1 over 4. So I hope this made sense to you guys. If you found this helpful, please like the video, share it with your friends, and let me know what you think down in the comments below. You can join the channel by clicking the subscribe button down below, and ring the bell so that when the next video comes out, you'll get notified about it. Thanks so much for watching, guys. Have a good one, and I'll see you next time.